height? The lamp's height. Very good. So the height is 10 for the lamp and then 6 for the guy. Okay, now think about what we did yesterday. Okay, we were doing similar triangles. It's going to be kind of the same thing here. You have one triangle. You might have glued in the wrong problem. There's 2 problems of guys walking. Did you accidentally glue in the wrong one?
I didn't glue in. I just looked at the sheet.
Oh, okay, so then yeah, look at the one right below that one, because there are 2. Okay, and then here's our big triangle. Now, because these are side angle sides, similar triangles, we can make a proportion of those sides. So, find given when equation. Okay, these are similar triangles. Now, what are the things that are changing? 2 things. The guy's what? Shadow. I'm going to label that S for shadow. And then also, the guy's not staying in the same place, right? He's walking. So I'm going to label that X. Okay, so what do we know about how fast he's walking? What rate is he walking? So dx dt is 3. What do I want to find? His shadow, that would be ds dt. Then for my when, it doesn't really give me a when. So I'm just going to put a question mark. Okay, I'm going to give you the ratio of the pink sides on that triangle, and I want you to do the ratio on the big one. So I'm going to put 6 over S. What would be proportional to that on my bigger triangle? 10 over what? 10 over X plus S. Very good. Now think about why, because if I want to make these proportional, I need to use the height over the whole base. So I'd be adding those, yeah? Okay, what I want you to do now is cross multiply and then simplify it to where you don't have multiple S terms. So what is S times 10? 10S. And then on the other side, I have 6 times X plus S. So I'm going to have to do a little bit of distributing there. So that'd be a 6X and then a 6S, yeah? So 10S equals 6X plus 6S. Now, I could take the derivative at this point, but I have S's on both sides. That's annoying, so let's get them together. So minus 6 here, minus 6 here. And what is my final equation I'm going to take the derivative of? But combine like terms. So 4S equals 6X. Now, when I take the derivative, I'm taking the derivative with respect to time. So what's the derivative of 4S going to be? 4 ds dt, yeah? Because you have to keep the 4 in the front because that's the derivative. And then the derivative of 6x would be what? Good. And then from there, what are we plugging in? Our dx dt was 3. So 4 ds dt equals 6 times 3. 6 times 3 is 18. Then ds dt would be 18 over what? 4. Are we good with that? Okay, so you want to look for similar right triangles. That's going to a lot of times help you write your equation. Okay? Come back to your green sheet, please. Next one that we're going to glue in is going to be, let's do at the instant when the radius of a cone is 3. At the instant when the radius of the cone is 3. Right here. Did we do this one yesterday? We did not, right? No. Okay. Oh, why is my door locked? Okay, so glue that one in for me, please. And then I want you to try to fill in your find given when, and I'm going to bring you a little cookie. Okay?
Wow.
Kristen, I think you're smart.
I have to do this with every day. She makes fun of me. You think I'm smart with Joiner?
Oh yeah. A little lazy, but smart. You know, you have two kinds of people. The people that have to try really hard to get it, and then the people that it just comes almost so easy that they turn lazy. That might be harmful too. Find DRDT. That is right. Then your given is what? And then your radius is 3. Okay, then your equation, you're going to have to do a substitution. So if they, did I give you a copy? Okay. So it says the height is 3 times the radius. So you're going to replace height with 3r. And then take the derivative after that. You're welcome.
Yeah, I'm actually.
You're about to.
I'll figure out
You just needed the cookie first to seal the deal. This? You're welcome. Okay, you're going to have to do a substitution on this one. So if you haven't started yet, okay, know that's going to happen. Wow, I can't believe you can do that. Now your guy doesn't have muscles so far, but... You're welcome. We're doing... this one. Do it quick call. The first number 3? Yeah. That's the one. Huh? Next time, though. Cookie for you, Marcel. Is there something going on that so many people are gone today? Y'all know?
There's some ROTC.
ROTC and what else?
Your mediators are on a trip.
Just out there mediating their peers, you know?
They're on like a group.
Oh.
Yeah.
Alright, so you should have started with your find is what? Hopefully we got that.
The rate
Of which thing though? Okay, so DRDT. Okay, what's my given? DVDT is 9 pi. Okay, and it says increasing, so I'm kind of like picking the positive in my head. Okay, then when? Did it give us a when?
Yeah, radius.
Okay, so it says the height is always 3. So is that really a when? Let's skip it. Okay, we can put it here. Let's say height is always 3 times r and then put a question mark. Okay, then my equation is volume equals 1/3 pi r squared h. Now, we talked about this yesterday. If you took the derivative right now, that's a product, you'd have to do product rule. The only way to avoid that is a substitution. That's where this is going to come in. If my height is 3r, I'm going to take my height out. I'm going to put a 3r in instead. Now, do you remember yesterday we were subbing the r out to get the h? That's because we wanted dh dt. What do we want this time? So we have to keep the r and get rid of the h, yeah? So I'm going to do v equals 1/3 pi r squared times 3r. And what's going to happen with my 1/3 and my 3? And what's going to happen with my r squared and my r? It's going to be pi r cubed. Okay, take the derivative of that. What would the derivative be there? dv dt, right? Start on the left. And then on my other side, I'd have my 3 come down to the front. pi r squared dr dt. Oh, and I did miss, it says right here at the beginning, when the radius is 3, sorry. R equals 3. And the reason we know we need that is because it's in our equation, right? So dv dt is 9 pi equal to 3 pi, my r is 3 squared, my dr dt is unknown. And then from there, what is 3 squared? 9 times 3 again. So that'd be 27 pi dr dt. And then from there, if I want to solve for dr dt, I'd have to divide my 27 pi to the bottom. So it'd be dr dt equals 9 pi over 27 pi. What's going to happen with the 9 over 27? That would reduce to 1/3. And then notice my pi's would go away because they cross out with each other. Yeah? Okay, there's one more that I want us to do off this sheet before we move on. And it is the balloon is being filled with air at a rate of 3. That one right there. Can I raise it? Sure. Is that good? Okay, you're doing this one right here. A balloon is filled with air. Go ahead and try to set that one up next. See if you can do this setup on your own. Yes? Well, okay, so if it says when the radius is 3, that means that it's changing. So if it's a when, you should be plugging it in after the 3. The only time you should plug in before is always true. So that's why on this one I was saying, well, it's not really a when because the height is always 3 times the radius. Well, then you can plug it in before. Kind of like here with the pole and the light, or the pole and the guy, it's like they're always that height. It doesn't matter where they are in the picture. So if it's fixed, you can plug it in as the beginning. But if it's something that's changing, then you have to wait to put it in the slot. Okay? The radius is changing, but the height is always 3 times the radius. So think about as your radius gets bigger, your height is just staying 3 times that big. But they are still both changing, but they're staying at the same relationship to each other. Okay, so let's see what we need on this one. What are we finding? dr dt, what were we given? Okay, and then you wrote down hopefully your when. What's your when? Okay, good. So go ahead and take the derivative for me. We've done this sphere now a couple times. So we're finding dr dt. Our given is dv dt is 3. And our when is when volume is 36 pi. So my equation here, v equals 4/3 pi r cubed. When I times the 3 down, I'm going to write my dv dt on this side. Okay, 3 times 4/3 is what? 4 pi r what? Then dr dt. Then we get to here, we're ready to plug in. My dv dt is 3, right? So I'm plugging in 3 equals 4 pi. Then I get to r squared, and we have a problem. Did they give us r? What did they give us instead? Volume. But if we know the volume, can we work our way back to find what the radius was? Yeah, so it's kind of like on Pythagorean theorem, where it's like they give you 2 sides, but they don't give you all 3, and you have to go back and find it. So we're going to go back and find r using the volume they gave us. So 36 pi is the answer for 4/3 pi r cubed. How am I going to get rid of 4/3? Multiply by what? 3/4. So I'm going to put a 3/4 here, and then I'm going to cross out the 4/3 to make it go away. Now, when you're multiplying, you can multiply or divide first. It doesn't matter. What is 36 divided by 4 first? 36 divided by 4 is 9, and then 9 times 3 is 27 pi equals pi r cubed. Well, then next I'm going to divide by pi. That means that 27 is r cubed. Well, then I need to take the cubic root of 27, which is what? Then r is 3. And so now I can come over here, bloop, plug in my 3, and then I'm ready to keep solving. 3 squared is 9 times 4 is, so this is a 36 pi r, or I'm sorry, dr dt. And then from there I'd divide by the 36 pi, and I'd solve for my dr dt. So it'd be 3 over 36 pi. Make sense? Okay, great. Alright, we are going to move to the pink sheet, and we're going to start doing a little bit of trig. So before we do that, I'm going to give you a rando triangle, and I want you to see what you remember from your trig. Trigonometry. Okay, let's say that you have a triangle. We'll say it's a 6, 8, 10. So this will be 6, 8, 10. And let's say that this is my angle here, theta. I want you to find, this appears to be no number, that is an 8. Okay, I want you to find sine of theta, cosine of theta, and tangent of theta. Okay, just before we kind of get into it, you should remember SOHCAHTOA. So remember that the angle of the triangle is related to the sides. You would have to do a ratio. So if it's sine, which sides are those? Opposite over hypotenuse. So what is the side opposite to my theta if it's in this corner? 6, and then what's my hypotenuse? 10. So it'd be 6 over 10. Okay, so that's AH. A stands for adjacent. So if this is my angle, what is adjacent to that? 8, and then what's my hypotenuse? 10. So that'd be 8 over 10. And then for my last one there, for tan theta, it would be which two sides? That's SOHCAHTOA. So that'd be which sides? 6 over 8. Now, you are going to use SOHCAHTOA. Use SOHCAHTOA when you don't know theta. Okay, now let me explain what I mean by that. If I knew theta, I just find the sine, say theta is pi halves. I just find the sine of pi halves and I'd be done, right? But if I don't know theta, that's when I would say, okay, what are the sides of my triangle? And then I would try to go from there, okay? So the first example that we're going to do off your sheet, this is your pink sheet, is going to be the very top one about the spy. Okay? The very top one about a spy tracking a rocket. Does anybody need a sheet? Let's just pick one up. The spy tracking a rocket. And then I think I told y'all, but we are doing more notes tomorrow, so you do not have a quiz tomorrow. But you will on probably Monday. Okay, so it says, a spy tracks a rocket through a telescope to determine its velocity. The rocket is traveling vertically from a launch pad located 10 kilometers away. At a certain moment, the spy's instruments show the angle between the telescope and the ground is pi thirds. It's changing at a rate of a half radians per minute. What is the rocket's velocity? Okay, so we have a launch pad. And then we have a rocket that's traveling up. So here's our rocket. Okay, there it is. Has little wings on it, of course. Okay, the rocket's going up. Okay, then you have a spy over here on the ground. Okay. His legs are broken, apparently. Okay, and he has an instrument. I guess he should ideally be looking through the telescope, but that's okay. Okay, there, oh, he's in a bush. Okay, because he's a spy. Okay, notice you've drawn a what shape? A triangle. Okay, boom, hopefully. Okay, so it says that he's tracking the rocket. He's 10 kilometers away. Is that always 10? Or is it changing? He's laying on the ground. He's 10 feet away. That's always true. 10 kilometers, sorry. Yeah, 10 feet, he'd be... Yeah, he's way too close to the rocket. Okay, then it says the rocket's going up. Is that going to be changing or the same? Changing. So I'm going to call it Y just because it's up and down. And then we have his instrument that's following the rocket. As the rocket goes up, what's going to happen to the angle? It's going to be changing or fixed? Changing. So we're going to use theta. Okay, so find given when. And I want you to try to fill out some of it. Find given when and then equation. Now, I'll help you with the find. We want the rocket's velocity. So think about, if this is his position, what's the derivative of position? Velocity. So they're asking you to find dy dt. Okay, because that's the rocket's velocity. So that's kind of tricky, but think about it. If you know his position, the derivative of that is velocity. Dy dt is another way to say that. Okay, so we want dy dt. What were we given? How fast is the angle changing? Okay, so d theta dt is a half. Now, I'm going to just abandon units at this point because it gets too confusing, but angles are measured in radians, so that's why it's radians per minute. Okay, then what's my when? Okay, pi thirds. Very good. Now, that would be theta as pi thirds, yeah? Okay, so now we need to pick an equation. Your choices are sine, cosine, or tangent. That's going to relate the sides of the triangle that we care about. We care about this side, and we care about this side. Tangent. Okay, so set up tan theta equals. Opposite is what side? Y over adjacent is 10. Now, if I'm going to take the derivative of this, am I going to need to use quotient rule here? Or can I fix it by rewriting? Okay, I can avoid it by doing this, look. 1/10 y. Yeah? Because 10 is not really its own function, it's just a constant. So I'm going to make it a 10th y, now we're going to take the derivative. What's the derivative of tan theta? Secant squared theta, then what? D theta dt, right? Because that was what my letter was. If it's a theta, I have to put a d theta dt at the end, just like on the other side. What's the derivative of a 10th y? A 10th dy dt, right? Questions are good so far? So if your angle's measured in theta, that's your variable. You'd put a d theta dt at the end. Okay, now we're plugging in our when. What's our when? Pi thirds is going to go here. So I now have the secant squared of pi thirds times d theta dt, which is a half, equals a 10th of dy dt, which is my unknown that I'm trying to find. Okay, let's do secant of pi thirds first. Secant is which one flipped? It's 1 over cosine. Good. So cosine of pi thirds is what? Here's pi thirds. Cosine's on top. Well, 1 over what? 1/2, yeah? No, it's okay. So cosine's a half, yeah, but then you have to flip it. So what would it be then? 2. So this is 2 squared times a half equals a 10th dy dt. Okay, let's solve that left side. What's 2 squared? What's half of 4? So really that's just a 2. And then if it's a 10th dy dt, how do I get rid of the 10th? Multiply by 10 here, multiply by 10 here. And then my 10 and 10th here cross out, dy dt equals what? Good. So it'd be 20, and then think about y was measured in kilometers, so this would be kilometers per second. Or actually it was minutes, sorry. Wow, that is a very slow rocket. It's like barely moving. Okay, good. Understand the basic idea? No. Okay, I'm going to give you another one kind of like that. We're going to do the angle of the sun. Okay, the angle of elevation of the sun is decreasing at a rate of. We're going to do that one next. Now, on the AP test, usually they'll give you a picture if you need a picture. Okay, so, and like if I give you a test over this, you're going to have the picture on there. So don't stress out about that part of things.
They don't make us cut out and glue stuff together.
They might, you never know, so. Okay, so it says the angle of elevation of the sun. Here's the sun. Okay, and it says it's decreasing at a rate of 0.25 radians per hour. How fast is the shadow cast by a 400-foot tall building? So here's my building. Okay, and there's his shadow. Okay, it says how fast is the shadow of the building changing? Okay, so I want you to draw your triangle. Okay, the length of the shadow is going to connect to the sun. That's your triangle. Okay, so right here, here's your triangle. Now let's talk about what side of the triangle is fixed. What is not changing? The building. How tall is the building? 400. So that is not changing at all. And then my shadow, I'm going to call it X just because my S's start looking like 5s. Okay, then from there, where's my theta if it's the angle of elevation? Is it this one or this one? Top or bottom? Angle of elevation would be measured from the ground. So it would be right there. Okay, so find given when. And then I want you to pick your equation. Remember your choices are still sine, cosine, and tangent. How fast is the shadow changing? What's that? Dx dt. What's our given? Yeah, the building is true, but it says the angle of elevation of the sun, right? So that would be d theta dt. And then it says it's decreasing at 0.25. So what would I put? Negative 0.25. Okay, then it says when the angle of elevation is pi sixth. So my theta needs to be pi sixth. Okay, look at your picture. What sides are we going to pick? Tangent again. Because look, this is my opposite. This is my adjacent. So I would do tan theta equals. My opposite side is 400. My adjacent side is x. Now, if I don't rewrite, I have to do quotient rule. So how could I rewrite that so that I don't have to do quotient rule? X to the negative 1. Good. So tan theta equals 400 x to the minus 1. And remember, I'm doing that to avoid quotient rule. Okay, take the derivative for me. Remember, you should get a d theta dt on the left and a dx dt on the right. What did we say the derivative of tan is? Secant squared theta d theta dt. And on the other side, I'd take my negative 1 down. Now it's a negative 400. My x is now to the what power? Negative 2, then dx dt. Very good. Then from there, I'm going to take my x to the negative 2. I'm going to make that like a fraction. So it'll be secant squared theta d theta dt equals negative 400 over x squared dx dt. Okay, to there, any questions? Okay, we want to plug stuff in. Do we know theta? Yeah, what is it? Okay, secant squared pi over 6. Do we know d theta dt? Negative 0.25 equals negative 400 over, do I know x? No, we're going to have to find that. And then dx dt. Now, this is where all of the stuff that seems so useless for Evergo and TRIG is going to come back. Now, there are not a ton of these on the AP test. Okay, but again, this is for that, like if you're an excellent student, you should be able to do this. Okay, think back to when you're in TRIG or in geometry. I know pi 6th, right? What is the tangent of pi 6th in the triangle going to be equal to? Which sides? 400 over x, right? Can I find x? You should be able to. Now, you'd need a calculator, and they took mine away for the pre-ACT. But I'm going to do it up here for you. What would I do first? Oh, you can see it. Okay, I'm going to find the tan of pi 6th. Now, you could do that by hand if you want to, but you need a calculator eventually anyway. So we're going to do it here. So 0.5773 equals 400 over x. What would I do next? Multiply the x up. So 0.5773x equals 400. And then what would I do last to solve for x? Divide 400 divided by 0.5773. And it's 692, oops, I put my decimal in a weird spot. Ooh, 0.88. We're going to round that to 693 just because this isn't the real AP test and it'll make our numbers easier. Okay? So over here, we had to go back and find x because it wasn't given. Okay? So I'm plugging in 693 right there. Okay, from there, secant of pi 6th is cosine of pi 6th upside down. What is the cosine of pi 6th, which is this one? Root 3 over 2, but I have to flip it. So it'd be 2 over root 3, quantity squared. And can I just go ahead and square that before we keep going? What is that on top? 2 squared is 4, root 3 squared is 3. Okay, then times, what is negative 0.25 as a fraction? Negative a fourth. What's going to happen with my 4's? Good. 693 squared on the bottom. And so then for my very last step, I'm going to cross those 4's out. Really, it's just negative a third. And then I'm going to multiply by the reciprocal of this fraction to the other side. So dx dt is going to equal negative a third times 693 squared over negative 400. Yeah? So I took this right here, and I just multiplied by its reciprocal. Now, overall, how's the sign going to come out? Positive. And I want you to think about if that makes sense in my picture. So I'm going to come up for a second. As the sun goes down, is that going to make the shadow longer?
Yes.
Yes, that should make sense to you. Okay, that my shadow is getting longer if that rate came out to be positive. Okay? So overall, this is greater than 0. Then shadow is increasing in length. Okay? Make sense? We don't really have time for another one. Do you have any questions off your homework that I can just kind of like start without really doing for you? No, it's going to be due on Monday. So we still need to do tomorrow's notes too to really make you able to do all of it. 4. Did we do a ladder one already? We can do that one, but I would look at the ladder one in your notes. Because that one's really similar. The numbers are a little different, but it's really similar. 9 or 10. Let's do 10 instead. Okay, number 10, it says 2 points are moving along the axis to create a triangle with a hypotenuse of 10. So here's the x-axis. Here's the y-axis. Now, how long is their hypotenuse always? 10. So x and y are both changing, but 10 is fixed. Okay, then it says point x is moving away from the origin at 10. Point y is moving towards the origin at 4. What is dx dt? I'll read it again. Point x is moving along the x-axis at a speed of 10. 10. What will dy dt be if it's moving towards the axis? It's moving towards the origin at 4. -4. Very good. Okay, now if you do the find given when, like I taught you, I'm not really organizing this well, but that would be your given. Yeah? Both of those would be given, correct. Then it says when point y is at 6, so my when is when y is 6. It says how fast is the area of the triangle changing? So I'm finding dA dt. Okay? So I'm finding dA dt. Now, quick question. Those of you that are my Pythagorean triple memorizers. Okay, 3, 4, 5 goes together. 6, what, 10 goes together. Double them. 3, 4, 5 goes with 6, 8, 10. So if this is 6 and this is 10, what is x automatically? 8. Now, you could go back and find that if you have to, but 3, 4, 5, double it, 6, 8, 10, those always go together. Okay, so from here, how do I find the area of my triangle? 1/2 what? But instead of base and height, what letters? X times y. And then from there, when you take the derivative, what rule would you need? Product rule. Very good. So your u would be 1/2 x. Your v would be y. What would u prime be? 1/2 dx dt. What would your v prime be? dy dt. And so then my derivative of a would be dA dt equals, and then it would be 1/2 x dy dt plus 1/2 y dx dt. And then from there you just be plugging stuff in. So it'd be 1/2, my x is an 8, my dy dt is a -4, 1/2, my y is 6, my dx dt is 10. Then what's 8 times -4 here? -32 cut in half is -16. 6 times 10 is 60, cut in half is 30. What is -16 plus 30? 14. Now, quick question. If my DADT came out positive, what's happening to the area? Overall, it's increasing or decreasing? Area was positive, so it'd be increasing. Very good. Okay? All right, and then I will send out, if there's one or two that you can't figure out, let me know and I'll send a video out tomorrow to help y'all over the weekend if you need it. But we have one more day of notes still. Okay? Yeah. Well, isn't it 49 that it rings? It's only 47 right now. Is it 49? I don't know.
She's not into me, I said,
Yeah, it is 49.
I know, because he's like, why isn't she?
So you kind of quit on us a little early today, Colton. Wait 2 minutes, because the bells are not ringing because of pre-ACT.
So,